All right, welcome to a new chapter. We are on chapter 12, which is basic statistics. If any of you follow along with the book, I don't know that we're following the book very closely, so you'll just have to use the notes that we do in class. So the first part of this should be review. I know that you do this in middle school. So we're just gonna quickly review how to find the mean, median, and mode. So the mean is what we normally think of as the average, although all three of these are considered measures of average. The mean is the most common measure of average. So just something about the mean, it doesn't really come up today, but it might come up at some point in this unit. This X with like a bar on top of it is the symbol for mean. So in order to find the mean, you add all of the values together. So you add all of the entries, so each like individual number, and then you divide by the number of entries. Okay, the median, there is no like symbol for it really, but when we start doing more things on the calculator later, it is MED when we get to the calculator. But the median is the middle number. If the data set has an even number of entries, there will actually be two middle numbers, so you just average those, which we'll see in a minute. And then the mode is the most commonly occurring data value. So I'm just going to write occurs the most often. Sometimes a data set can have no mode, and it might have two modes. So we'll talk about that a little bit. So the mean, median, and mode, it says given each data set below, find each value. So it wants us to find the mean, median, and mode, even though it doesn't really specify that, but we're finding each of those measures of average for each of these sets. So there's a little note to arrange them in order from least to greatest first. So I'll do that on this one, although we actually don't really have to. So I'm going to show you another way of doing it on the next one. Sometimes I like to underline them to make sure I don't forget anything. Then 10, 11, 12, there's two 13s, and there's a 34. So that's 1, 2, 3, 4, 5, 6, 7, 8 data values. So now that I have them in order, I guess I'll go, I'll start with the median. The median is the middle, so it'd be the middle of 11 and 12. It's pretty easy to like know the middle of that is 11.5, but if it's a little bit harder to tell, you just add them and divide by 2. But in this case, it's going to be 11.5. Just for the just for the sake of showing work, I'm going to show my work right here. To find the median, you would take 11 plus 12 and then divide it by 2. You would need parentheses around that, though, if you're going to type that in the calculator all at once. Okay, to find the mean, you have to add them all and divide by the number of entries. So for the mean, I'm going to show my work over here to the left. I'm going to use the symbol for mean. So add them all. They obviously like don't have to be in order if you're just adding them, but since they're already in order, I'm just going to add them. Okay, so I'm getting 107 for the sum of all the values, and then just divide by 8 because there are 8 numbers there. Divided by 8 is 13.375. It doesn't really tell us what to round to, so I guess I'm just going to write the whole thing down. 13.375. The mode is the most commonly occurring data value, so if it happens like more than once, it would be your mode. Looks like the only one that repeats is 13, so this data set has a mode, and the mode is 13. Remember, sometimes there is no mode. So that's the mean, median, and mode for that one. This next one, has 1, 2, 3, 4. This one has an odd number of data values. So I'm going to first write them in order, like I did the last time. Or actually, you know what? You don't technically have to write them in order. Sometimes it's a very long data set, so it's annoying to write them in order. So I'm going to show you another way of finding the median. You can kind of cancel them with each other. So in other words, the smallest number, which is 13, cancels out like the largest number if you imagine like working from both ends. So those two would cancel each other out. Then the next pair would be the smallest remaining value would cancel out with the largest remaining value. Then the next smallest number would be 20, would cancel out with the biggest remaining number, which is 21, which means the middle number is 21. If you find that annoying, just put them in order. It doesn't, you can do them the other way too. So the median is going to end up being 21. And if you want to put them in order to find that, that's fine. You can use the abbreviation for median, or you can write out the whole word. The mean or the average, you're going to add them all and then divide by how many there are. So I'm going to add those all. I got 140, and then divided by 7 because there's 7 values. So the average is 20. And then the mode. It looks like 21 occurs twice, and that's the only one that repeats. So the mode would be 21. Remember, sometimes a data set can have 2 modes. So like, for example, if 18 were to occur again, this would be what we call bimodal, and it would have 2 modes, and you would list both of them. Then we have a working backwards one. It says Quinn's test scores are 95, 90, and 83. What must he score on his next test to have an average test score of 90? So when they're talking about the average in this type of case and they don't specify which measure of average they want you to use, you want to use the mean. So we want the mean to be 90. So we're trying to figure out what he should score on his next test. So that's kind of like our x value. That's our variable that we don't know. So we're trying to figure out what x has to be. So in order to find the mean, you add the data values. So I'm adding his test scores together, plus the one that I don't know, which I'm just going to call x. To find the mean, you add and you divide by how many there are, which is 4. And we want that average to equal 90. So now you just have to do the algebra to solve that for x. So I'm going to add these numbers together that I'm highlighting. 95 plus 90 plus 83 is 268. So I'm getting oops, that highlighter's not going to work. I'm going to get 268 plus x divided by 4 equals 90. Then you want to get rid of the divided by 4. So to get rid of the divided by 4, we always multiply by 4. So I'm going to put times 4 and then times 4. So when I do that, these cancel. So I get 268 plus x equals 360. So then to solve that for our unknown test score, or x, we're going to subtract 268. So 360 minus 268 is 92. So he must score a 92. This doesn't say that they're percents, so I'm not going to put a percent symbol on it. So that's that one. There's a U try there. It's kind of the same way like we just did, but it says Frank wants to have a bowling average of 215. The first 7 games he scored 159, 182. It gives you all of his scores. And it says, what must he score in the 8th game to have an average of 215? So why don't we go ahead and pause the video right now, just for a minute or two. And I'm going to try this and then restart the video, and we'll just make sure our answers are the same. Okay, so I wrote this one out. I added all the numbers together, and I got 1434. I suppose I could have pushed a button wrong, though. But plus x, the one we don't know, divided by 8 equals 215. To get rid of the divided by 8, I multiplied by 8, and then I just did the algebra to solve, and I got 286. So he's going to have to score like significantly higher than what appears to be his average in order to pull up his average to 215. So the next thing is talking about comparing measures of center. So measures of center are all these that we're talking about. So it's the mean, the median, and the mode. They typically represent the center of a data set. So it wants us to find the mean, median, and mode of these hourly wages. So I'm going to do that. The mean, we're going to add them all and divide by the number of entries. So the mean, I'm going to give you guys a minute because I'm going to do it along with you. I'm going to add all those on the calculator. Again, I definitely could make a mistake. I've done it before. So if you feel like I added them wrong, I might have. I'm going to add them all. I got 77.2. And then, so hopefully you did too, divided by 8. So the average is 965. This is money, so I'm just putting the unit on it. The median and the mode are the remaining things. So the median, you can either put them in order or do the canceling thing. I'm going to do the canceling thing, but you do whatever you'd rather do. And then the mode is the most common occurring data value. Does any of them occur more than once? I'm not seeing they all look, oh, nope, sorry. There are 2 8.25s and then nothing occurs like more than twice. So the mode would be $8.25. The median, I'm gonna do the canceling thing, but if you'd rather put them in order, that is fine with me. So the biggest one would like cancel out the smallest one. The smallest one is 8.25. Then the next biggest one, which would be 9.25, would cancel out the next smallest one, so the next one that's remaining. The next biggest one, so the biggest number at C, would cancel out the next smallest number I see. So the median should be the middle of 8.75 and 8.65. Hopefully we can tell the middle of those would be $8.70. But remember, if it's ever hard to tell, you can add them and divide by 2. So there's your mean, your mode, and your median. Which measure of center best represents the data? It kind of sounds like an opinion question, but honestly, there is a correct answer. You want to, whenever there's what we consider an outlier, which we'll talk more about in a second, which is a data value that's much bigger than the rest of them, which in this case 1650 is an outlier. What happens is that really impacts the mean. It like artificially pulls it up so that the mean, which is $9.65, doesn't really represent the average very much. So typically if there's an outlier, you want to say the median is the best measure of average. We don't usually say the mode for this question. It's typically not the best measure of average. So this is the median. And then it says explain. I'm going to say 1650 makes the mean higher than almost all data values, which makes it not a good measure of average. Again, we don't typically say mode for that question unless it's like not numerical data, which we'll talk about in a little bit. There's a U try. I'm going to skip that for now because it's like the same thing we just did. So more stats vocab, I actually ended up just talking about this, but an outlier is a number that's really small or really large compared to the rest of the value. So values. It's really small or really large compared to the other data values. It says, using the data from the hourly wages example we looked at earlier, complete the following. Identify the outlier. We already said 1650 was the outlier. How does it affect the mean, median, and mode? In other words, find the new mean, median, and mode and see what happened to them. So the mode is not going to change. The mode, typically, unless it was that outlier, remains unchanged. The mean and the median can be impacted by outliers, but the mean is going to be way more impacted by outliers than the median. So the median, now we have, let's see, we have 7 data values left. So the middle one is not going to be the middle of 865 and 875 anymore. The middle number should be 865. So you can go ahead and confirm that if you want to. So it only went down 5 cents because before it was 870. Yeah, so it went down 5 cents. 5 cents. The mean you'll see is really impacted by the outlier. So mean, I'm going to use the symbol for mean. We're going to add all the remaining data values. So pretend that 1650 isn't there anymore. So I'm going to add those all, or you know what would be faster. I'm going to take the sum that I got up here, which is 77.2, and I'm going to subtract that 1650 from it. So hopefully that was the right number because I'm using it again. I'm getting 60.7, and then I'm going to divide by 7 because there's only 7 wages now. So then the mean is approximately $8.67. So the mean went down a lot from what it was before, like almost a full dollar. So down almost $1. So it did have a big impact on it. That's a significant impact when the numbers are kind of small like this. So it says describe one possible explanation for why this outlier was there. In other words, why would all these numbers for the wages be small and then have one that's a lot larger? So we actually did the same thing in my algebra classes a few months ago, but because I'm not in the room with you, I don't know what you're thinking, but most of them said that that person is probably like a supervisor of the other people, which is accurate. So that's probably a supervisor wage or someone who's in charge or a manager. So I'm just going to say it was possibly a manager's wage, like someone who's in charge or has more duties than the rest of the people. So that's why it was there. A little bit more vocab here. So numerical data is exactly what it sounds like. It's numbers. And then categorical data doesn't have numbers to it. So sometimes we call this just another name for this. Sometimes we call this quantitative data. So in other words, it's numbers based. A quantity is like a number. Categorical data is different. It doesn't have numbers to it. We're still collecting data, but it's what we call qualitative, and it's not numbers based. So sometimes you'll be given like a description of a data set, and you'll just have to say, is it numerical or categorical? So eye color, if I were in the room right now, I would say, what are some possible eye colors? And you would say like blue, brown, green, etc. Those are not numbers, and we can't really assign numbers to them. So that's certainly categorical. Amount of hours spent on social media per week. Same, if I were to ask that question in the class right now, you would be shouting out numbers, which are probably too large for what you should be spending on social media. But anyway, that is numerical, because you would answer it with numbers. GPA is also numerical. It has numbers. Favorite TV show, definitely not numerical. So if I ask you your favorite TV show, you're not going to answer me with a number. So that's what we call categorical. So a couple categorical and then a few numerical. Then we're talking about frequency tables and how to find the mean, median, and mode from those. And then just one more thing when we're missing a data value. To find the mean, median, and mode of frequency tables, the process is a little bit different. So a frequency table just kind of like, instead of listing out all of the individual data values, they're arranged in this way because it does like save some room and some time. So this first row, for example, means that 8 students have 0 siblings. So 8 people have no brothers or sisters. Then the next row means that 5 have 1 sibling, etc. So we could write out all of the data represented by this chart. So I would write 0 8 times, then I would write 1 5 times, etc. But it would be kind of time consuming. So you actually don't need to do that in order to find the mean, median, and mode. So the mode is just going to be the one that occurs the most number of times, which we can tell pretty easily in a frequency chart, that the data value 2, so 2 siblings, occurs 10 times, and that's the highest frequency. So the mode is always the one that goes along with the highest frequency. So the mode is in this case is 2, because that occurs 10 times in this data set. The median is the middle number. So to find the middle number in a frequency table, you want to figure out how many total people there are. So to do that, you're going to add the frequency chart. So 8 plus 5 plus 10 plus 7 is 30. So there's 30 total like students probably represented in this chart, the number of siblings that those students have. So now the median would be between the 15th and the 16th value, because there's 30 total. So you certainly could write them all out, but actually we can use the frequency chart just to see which category we'd be in. So if we count from the top like down, there's 8 students here. Then if we add these 5, that's 13. We need to go between the 15th and the 16th. So the median would certainly be like somewhere in this category. So the median is also 2. So the median, I'm going to say, also equals 2. So the mode is 2, the median is 2. You can also count from the bottom up. Remember, we need to go between the 15th and the 16th value. So if we go this way, this is only 7. I need to go between 15 and 16, so it would be somewhere in that same category. So the median is 2. If that's confusing to you, you do have the option to write them all out. But if there's a ton of data values, sometimes that's hard. The mean. Okay, so to get the mean, remember we add them all up and we divide by the total number, which is 30. We already found that. So to add these all up, rather than writing them all out, 0, 0, 0, etc., what you want to do is you want to multiply. So 0 times 8 is 0. So there's 0 total siblings represented by that first row. 1 times 5 is 5. 2 times 10, so I'm just putting little times there, is 20. So 20 total siblings there. 3 times 7 is 21. So these are the total siblings. For each row, add those together. 0 plus 5 plus 20 plus 21. That's the total number of siblings, which is 46. And divide that by the total number of entries. So the sum of these is 46. And then we divide by the total number of entries, which we know is 30. So 46 divided by 30 is going to be our mean. It's 1.53. Now you can't have 1.5 siblings, but we still do want to list that as our mean to show that the mean is between 1 and 2 siblings. So the mean, median, and mode from a frequency chart is a little bit more complicated. You don't have a ton of those on your homework, but it does show up on there. Just some general questions regarding it though. So the last thing is just finding missing data values. So sometimes we don't know each individual entry, but we have information about the average. So here's an example. It says the mean test score of a class of 10 students is 80. If the high score is removed, the new mean of those 9 students that are left is 78. And it says, what was the highest score on the test? So on this one, I would realize that to find the mean, use the symbol for mean, we always take the sum of all the values and we divide by the number of entries. So in this case, I'm just gonna write number of entries first. The original mean was 80. So I'm gonna plug that on the left side. The number of entries was 10 originally. So solve that for the sum. We don't know each individual data entry, but we do know the sum originally was 800. So we can use that information. So now what we're going to do is we're going to take away the highest score. I'm just going to call the highest score x in my equation, and we'll solve for x. So if we're taking away the highest score, our new sum is going to be 800 minus x. So when we fill out our equation for the new mean, so they take away the highest score, and the mean becomes 78. So the mean equals the new sum, which was the original sum, which was 800, minus the highest score. And then this is only for 9 data values. So that's our setup, and we're just going to use algebra to solve it. So get rid of the divided by 9, so multiply by 9. 9 times 78 is 702. So you have 702 equals 800 minus x. To solve that, you can probably tell by looking at that the x is 98, but the actual math of that is minus 800, negative 98 equals negative x. So therefore, if we multiply or divide by -1, x is 98. So the highest score must have been 98. There are different ways of reasoning through that. So if you can figure out a way to show work and get 98, even if it's not the same way as me, that's fine. So that is it for today's lesson. You probably have time to finish the homework now, so the sub will pass out the homework. If not, it is homework and it's due tomorrow, so when I see you tomorrow. Tomorrow we will be doing another lesson. This is a really quick unit, and your test is next Wednesday, which is June 5th, I believe. So just 5 lessons. All right, I will see you tomorrow.